All right, thanks everybody for joining us for today's CISL seminar. We're pleased to have Martin Bergemann from DKRZ, which is the German Climate Computing Center, here with us today, and he's been here with us in CISL as a visitor the past couple of weeks, working to install the application called Freva, which is the focus of today's seminar. So thanks again for joining us, and we look forward to your talk.
Thank you. Yeah, thank you for having me. First, as a disclaimer, I think like all typos that you will see in the slides are intentional and for your amusement. So anyway, yeah, my name's Martin. I work at the German Climate Computing Center, or this is there the DKRZ, which is a German acronym. And I am one of the developers of this software called Freva. And I've been here for the last 2 weeks to set the software up in the Kubernetes infrastructure that you have at CIRIS. And it is working now. And I just want to give you a quick overview of what this thing can do and what we're actually trying to solve with it. So, but before we dive into the details, I just want to give you like as sort of an overview or like a thing to give you like mention that the three main problems I think that scientists within this community are facing. So one issue is like searching and finding data. So data sets become bigger, larger, more complex. You know, model data sets, the models become more complex in terms of like not only computational complexity, that they have higher resolutions, but they also become more complex in terms of like processes that they're describing. So that means there are more variables, more things that needs organizing, and higher resolutions also mean that there's need for like more sophisticated observational data sets, and there's like plenty of observations out there. We have like super duper satellite products, and all of these things becoming more and more complex, so it becomes more and more harder to handle and to actually know where stuff is. And also we have like different file systems. There's not only the HPTC file systems, but now there's also S3 becomes more and more popular. And this is like spread everywhere. And so accessing and finding data becomes more and more of a problem, I guess, for scientists. And then the other issue that many people in this community are facing is they might be very good at writing code and scripting because they know what they're doing. And that's one thing, but like the other thing is essentially making their tools ready for other users that they can use this. So it's one thing. So you might be good at like because you know your code like in and out, but then if someone else wants to use that, and which is a good thing because you want to also gain visibility, then you have to do something that it's easy for them to use, and we try to offer them a solution for that. So to make it quote unquote effortlessly, that other users can use the code. And then the holy grail, I would say, is reproducibility. So that's been a thing, and we're trying also to achieve that. We're not like, I'm not saying that we achieve reproducibility, but we're aiming at like having sort of a maximum in what we can do of reproducibility. So, and I also do acknowledge that there's plenty of solutions within this community that try to like tackle some of the aspects that I just mentioned. And yet another solution is basically Freva or Freva, and it's a multi-component software framework. And I'm just going to give you here a quick why this is and why I also we from DKZ were invited to set an instance up at CISL. And so the tool itself has been sticking around for some time now. It's been developed since 2012, and it was specifically done by the climate modeling community for the climate model community. And over the course of the years, we added some additional features. We made it much more secure. We want to encourage the users not to change the way they code, but just to say, okay, you can use your code, you can use the programming language that you like, that you're comfortable with, and then just plug it into our system to generate a user interface for that. And as of now, at least at the DKRZ, is the most comprehensible, most complete metadata store. So we do have in the systems that we are running at DKRZ have like a couple of petabytes of data indexed or metadata indexed, not metadata, I mean data that belongs to metadata, no, other way around, metadata that belongs to data indexed, and a few million files, and like users can very quickly search through all of these and make use of this. And we also aim at having a sort of distributed architecture, so a server-client approach that like we offer the users a thin client that can be easily installed, and then a server that is managed by us that can like deal with the complex tasks of doing things actually. So this is just like here a little animation of how the user interface looks like, and we're trying to aim at having like different user interfaces so we can reach out to as many users as possible. So we do offer a Python and a command line interface. So here it's shown like just the command line interface, how it works. And then in Python works the very same thing. So you have this library that we offer, and then how they can search for data. And the very same thing we do offer, it comes with a web user interface where users can just intuitively click around what they're doing. I'm going to go into the details later about what that means. But this is basically our aim, is to have like this trinity of things that we have a easy to use web interface, and then for users who do not like to click around but they want to actually work on the HPC center, they have a command line interface, and the same goes for Jupyter notebooks, so that they can use the Python library, and everything works kind of like the same. They do the same job with some differences though. Okay, now I'm going to show you like a bunch of animations. I didn't want to live demo it because like maybe something wouldn't work and then wouldn't be as good. So I'm just showing here a few videos. So in terms of searching for data, I told you that I just showed you that we do have this this web interface, so that we can search through, and the users can like either search for anything, like you have like it's a key value based search. In this case, I'm just searching, give me everything that contains the Max Planck Institute, and then I can see, okay, here are the project names. So I'm just looking for anything that's where the Max Planck Institute was involved in the CMIP 6 project, and I can look for variables, and all these variable names, they can have like kind of weird names, and I can just look for radiation, for instance, and it will just show up everything that's related to radiation, and then like, you know, just collapse my search tree by looking for something. And then on the right-hand side, you can see the results here where the files are residing. It is fairly fast. And we also offer the option to show the users, well, if you don't want to use the web because it like, you know, you want to access the data in your script or in your, then you can just use this command to basically get to the same result. So that's essentially the idea. It's like the web is just an overview, but if you really want to get the work done here, use this command, and Bob's your uncle. So so then, as I said, like this is just a quick thing here, a quick video showing you the command line interface, how it works, and it works just like the same. If you bear with me, so you can search, like you use the data browser. There's also different applications like plugins and so on, and I will talk about this in a second. And then you can do your key value search pairs. So I'm looking here for the Institute of the Australian CIRO, and then for a variable lower radiation or surface radiation. And so then I would just get the results, and this is the locations on the thing, and I can just pump that into a script and then can just open the data sets. So I don't need to know where they are and when they have been updated and what kind of schema they follow and whatnot. So it's just there. So you just do your search for the key value pairs, and then you get your result. So this we do also offer in the website at least additional more features. So that's not all. So you've seen on the left-hand side these facets, and they might be not really suitable for everyone. So we have like predefined facets, 4 predefined facets. For instance, like there might be people who are interested in regional modeling, and for instance for Cordex or that. So we offer like for instance for them a domain facet, because it might make more sense if there was like, okay, domain give me everything over the US or over Europe or whatnot. So they can do that. And if that totally doesn't make sense for this 4 different search flavors, we also offer the users that they can actually just like define their own search flavors. So if there's like an observational person might be coming that's like can be totally different, and they just can customize the system so that it's basically fitting for their needs. Users can also add their own data set to the metadata store. So there they can do whatever they want. So we do have users also that use the system where they have indexed data that is on their laptop because it's just for them and that's good for them. And this is also fine. Other users are not bothered by that. It's not in the central search index, but then they can say like, hey, give me everything that is under my username, and then they can search this, and then they combine this with like what's centrally somewhere stored. So this is kind of nice. We also do offer now, as of like a couple of months ago, the option if like people do not like the style of our data browser with this search tree that is collapsing, you have to go through that. Like a completely different approach is the stack catalogs. I'm sure that many of you have heard about it. And we also offer that, like it speaks with the same API. It's just like different way of viewing things. It has some nice features in terms of like, spatial coverage and whatnot is there, and like annotations of data. And like there is some potential to it, but there's also some downsides about that. And but anyway, so we also do offer that. And we also offer like for users who have already predefined workflows, like I'm using intake or static stack catalogs, and I don't want to change. I don't want to completely change that. So we also do offer the option for them to just like make a data browser query and then just download a catalog for that and then use this catalog. So for instance, like if someone uses an intake catalog and like all this data processing is based on intake, they just have to add one line on the top that just adds, like creates dynamically this intake catalog for them, and then they can just go ahead and open it and just don't do anything or don't change much of the code. And one feature that we also do have, which is actually kind of popular for the users, that they can just log on to the website and then just click then an inspect metadata button, and then the data set itself just like pops up and is represented in this total ripoff of like how Xarray is doing HTML representation of a data set. But that's been very, very nice. And the users use, at least our users, they use this a lot because they look and say, hey, what's this? And then I just have a quick look there. This is that. And so this is how that looks like. Okay. So then you can just go ahead and maybe like decide if you need that or not. So another thing is accessing data. So there are multitude of things that can be done about accessing data, and especially remote access is a thing now. Because imagine a scenario where someone is like did model simulations at like a HPC center A, and now wants to compare this with observations from data center B. So either they have to download the data, or they need like tools like Globus, or the data needed to be on an Amazon, or not Amazon, but on an S3 storage, and so that they can access this. So this can be kind of tedious. And so what we were thinking of like a way of, why don't we do this dynamically? So we do have a service where users can just search for data as they are with this key value pairs. And this is here shows you some Python example. And instead of just telling the thing, just give me the locations where they are located on our file system, convert that with this little stream ZAR Boolean, convert that directly to ZAR, and then you will get these like kind of weird looking URLs back from the system, which are just UIDs, and this is cached data then, and then they then can just access it after they have been authenticating with the system. So, and this is basically how that works. So you basically chuck that into Xarray, and you just give it the token with that you have been authenticated. And we also offer like an easy way, a CLI way of or Python way of authenticating the web, where you can also like copy and create tokens if that's too complicated for the users. So because that's the easiest way. Anyway, so they have this here, they can just open the data set and then it's there, it just opens. It's not as fast, of course, if you would be directly at the file system, but it's convenient. And it surprisingly works surprisingly well, actually. And so that's like our take on like accessing data from anywhere. So that like the data curators, they don't have to worry about like moving the data somewhere else if they want to, so quote unquote, publish data sets. So this is basically all managed by our system. And then speaking of the user tools and giving the users user interfaces which they can play with. So this video here, you see on the left side, the command line version of this, and on the right side, the web interface. And what this a science plugin does, or science code does, it just calculates a climate change profile in like a 2-degree or 3-degree warmer world about a certain county in Germany. So it just cuts the county and then goes through a whole ensemble, big ensemble of model members, and just like calculates like a climate change signal and also the uncertainty with that. And that can be kind of complicated. And the person who set this up was an expert in that. And now me, for instance, I want to use that. And like, I don't have any clue about how to set this up, but like the Freva way is basically offering this user interface. And I'm just going to play that video. If you focus on the website, so you do have this automatically created form, which is like tool dependent. In this case, I'm just selecting my county here. I have pre-selected things which I could change, and then I make a connection to the HPC and submit a workload manager job. In this case, in our case, it's a Slurm job. Here it would be a PBS job. So users don't have to worry about that. And then I can see the output of this thing running here. In this case, it just executes a notebook remotely. And on the left-hand side, you can also see the same thing for the command line interface. So this is kind of nice because it lowers the entry level for like getting the hands on an HPC. People do not have to really think about like wall time, CPU usage, and whatnot. So this is all done by the people, by the admins who should know about this, and so that the users don't have to worry about that. So then in the end, once this tool has been applied and is done, so you get this nice little page here where you can just inspect the results. We have like all the output, plots or data or whatnot is there visualized. What is there in this case? I'm just gonna look at the climate change profile for this municipality in Jülich, where the Jülich Supercomputing Center. I think I recorded this for a talk that I gave there. That's why I chose the municipality. I would have done that also for Boulder, but it doesn't work for Boulder. It's only for Germany. So yes, exactly. So they have this user UI on which I then can say like inspect data, does it make sense or not? And then like, okay, yeah, that makes sense. So how does this work? So I mean, it doesn't like there is still some work to be done in order to create this user interface, but it should be very minimal. So that's all. Like our framework is written in Python, and so we offer this plugin API, and users basically have to define their own plugin within this plugin API. And that's the only downside about that, in my opinion, because many users actually, if you see here, they define this class plotting tool that inherits from their plugin abstract class. They really don't know what that means, I would say. But we do offer a lot of examples, and also we have to help them setting this up and documenting things, and that it's fine. They have like examples where they can just copy paste from like other tools, and that's fine. So we didn't have any issues with that, but still I would suggest that like this is really hard for someone who isn't really into programming to wrap your head around what that actually means if you inherit from this abstract class. It's probably also not the best name in terms of like, it's like make it easy to understand. But anyway, all you have to do is you just define a bunch of metadata. So like, you know, who you are and what like category this is. So we have like some tags on the website so that you can select different things and sort by different categories, and then version, and then the parameters. So it needs a file. It's in the Solar field is kind of special because then the web user interface knows, okay, if I want to input a variable, okay, now this comes a variable, so I make a drop-down menu. This will be searchable, so I make a query to the data browser and give me all the variables. I can also constrain that, so someone could set this here to give me only variables. I only want to be using variables from the whatever ERA 5 product. And so then the web user interface would just show you you can only select variables that are basically meeting these search criteria that the user who set this thing up meets. So, and then like this little run tool thingy there, function that is actually just getting the setup or the config of the tool, so with all its information, and then we just do a call, a sub-process call to the actual tool, and it can be anything. We have like a wide diversity of tools. We do have like Fortran, with C++, R. A lot of people use R, and this is basically how this is done. We recommend them. Okay, once you are there in this run tool function that calls it, you just dump the setup dictionary into a JSON file, and then if you want to use, so because most of the languages, they can actually support JSON. If you want to use shell, then use the JQ and to basically just like open the file and get like the information out there that you need. And that's been kind of good for the users and fairly easy. So we didn't have any issues on that side, actually, that they didn't really understand about this parsing kind of thing. So that kind of works. I'm not entirely happy about that, but I'm gonna show you in a minute. So after the plugin UI is loaded, you have like, and it's available to everyone. So everyone who runs this command just can see the new tool. So there's a bunch of plugins already defined. And then on the bottom here, you can see the new tool. And then you can also inspect the documentation with it and see like, okay, what kind of input parameters it needs. And if you do give the wrong input parameters, it will shout at you and saying like, hey, I can't do that. You need to do this and that. So that comes all within the framework. So that's like fairly easy with this regards. Okay, and in terms of reproducibility, what's our take on reproducibility? I'm just showing you like this little video. So we do offer this section here, the history section, where users can just jump back and see what they were doing actually in the past, which can be very helpful to work on their memory. And in this case here, we have this animation, and then you can see like, okay, this was the configuration that I did, and I can also go like jump just back right in, edit the configuration, and then the form will fill out everything with all the parameters, and I can just change it here, and then I can just like submit the job again, and then it will be running, and then just like as I showed before. So what you can also do is you can inspect like the metadata of this thing. Like you can see first of all also the plugin command if you wanted to do this from the command line. Here is like where this tool actually comes from. This is a GitLab repository of us. The internal version is just the last commit hash. So if something really goes wrong, you can just jump back there and restore it. And you can also share the results with others. So you can just send an email, select someone, and then send an email and saying like, hey, look at that. What do you think about this? So this is the way of like, we're trying to connect people and like, that they can like have a discussion and like make it a little bit more transparent what everyone is doing and like, get opinions, ideas, and things like that. You can also do the same thing with the data browser, just searching for the results, for all of the results and plugins that have been applied there. In this case, it's one of the guest users. This was just like a showcase. We have a guest user as a showcase, and you can jump right in there. You have like this little feature there with like show similar results to this, so that if you want to submit something, someone else has been doing this. It just like before you submit and waste computing time, why don't you look at here? And like maybe this person you don't even know about, they're doing the very same thing. And then you can just go and inspect their result and see what they were doing there and if that makes sense, sort of. Okay, and in terms of reproducibility, like each of these plugins, we use as a dependency manager, use Conda. We also offer guidance on how to create this Anaconda environments or Conda Forge environments, because it can be sometimes tricky with dependencies. And but so far it was okay. There was nothing that couldn't be solved. And then we also have documented and we encourage the users to freeze their Anaconda environments so that they can just like, if we basically roll out this thing on a new HPC system to make sure it's still kind of working. It's not like set in stone, but so far it's okay. It's okay, I would say. So this is basically our take on reproducibility. And here's the architecture, how the whole thing works from a technical perspective. So we do have a 3-tier layer architecture. So we have the client that makes a request. Then there's the reverse proxy. And then we do have the REST API that sits on top of it. It's basically the brain of everything that connects the dots. And so that makes like search queries to the Solr. The nice thing about this is also if like someone would say, and we are already working on that, hey, I don't like Solr, I want something else. I want a different backend. For instance, Postgres, because I guess from speaking of you, you use Postgres a lot. So we also do have that also in mind to that you can also switch different search, metadata search backends like Elasticsearch, Mongo, or whatnot. And then we also do have a MongoDB where the user data is stored, plugin data is stored. And the whole thing with the loading data and like on demand, the ZAR thing works basically with a broker that, or like with a cache, Redis cache, that also functions as a broker. And we do have a service that like needs to have physical access to the data, and that just gets requests and say like, hey, load this data from the broker, and then the data is like, okay, I'm gonna try to open the data and serialize it and then put it into the cache. And once the data is ready, the REST API can fetch it and pass it on to the client. So this is basically the idea about like getting this thing, and this is why we have this UID, or because it's in the cache. There's some cache evaluation involved after some time. The data would just be gone, and but if worse gets to worse, it just can be reopened. And of course, we do have an OpenID Connect system that tries to make this thing secure. So we do follow OpenID Connect protocol. We're trying to set this up here. Hopefully, will be done soon. So as of now, the system now doesn't work with OpenID, with the authentication authority here. But that's still something that I think it can be like solved hopefully soon. So, and then another thing, we also did some work on large language models. So we did actually wrote our own user interface, as you can see here, so that it fits into the website. Well, integrates with the website quite nicely. And users can just like make queries about whatnot. I just play this here, how this would be looking like. You can just make queries. There's like a bunch of like predefined questions, or you can just ask your own question, and then it makes queries, and so you get a response then. So this is all in real time. So then code is generated, and the backend in the back just massages the responses of the large language model to see if this is code, and then it executes the code on the HPC system. And so the users don't have to worry about anything anymore. Not submitting jobs, nothing. And then, and hopefully at some point you will also get a result there. There's this little picture, and then you can continue the chat with this thing. There are lots of caveats in it. We did try to use our own in-house Olama instance, was not as smart. So now we fell back to querying OpenAI, and there needs to be a key. So we also need to figure that out. But just the architecture, how this works. So the user has some input, then we do have a REST API that basically makes then the query to the LLM. And at the moment, this is then forwarded to OpenAI, and then the stream response comes back. The REST API inspects the response and tries to figure out what is code. And then once it sees that it's code, it's inspecting also in terms of security, because you don't want to trick the thing into thinking you're a system admin, and now you want to do things. If you want to install stuff, and so that stuff is then filtered out and can't be done. And then once this is done, this code is executed. It's serialized. The result of this is serialized and then saved to disk, so that like when another response is taken, so that the data from that last execution can be loaded quickly, and then like you can continue a conversation rather than like having to open the data set again and whatnot. We also, in the context, so we're using a context approach, and in the context we also told the LLM to about our library Freva, so it will always search for data. If you say, okay, give me the wind speed of the last 30 years, it will then just try to use the Freva data browser because it knows how to use that, and then do this. And so then the response is then streamed back to our front end and then presented there. So that's basically the main idea. So the heart of this is the REST API that makes queries to an LLM. It can be Olama, it can be really pretty much anything. We do have a couple of model options there, and then the code interpreter. We also want to go to more like a diverse settings using model context protocol and RAG systems, so that we don't not entirely just like rely on context and stuffing in context and making this like really heavy to do this. So this is but we are currently working on this. So this is just active stage of development. So other than that, like the LLM, what do we do? What are our plans for the future? So what I want to do, I've told you before that this tool API or the plugin API relies on Python, and users have to inherit from this, which I do not really like, and I wanted to have like more like a declarative thing, like for instance, like having this defined as a text base. So I like TOML. I'm not so much of a YAML fan, but it could also be YAML, and the users just have to declare stuff, input parameters, output parameters, and what needs to be called, and then this is somewhere saved in a database, and you can run this from anywhere, and and the content environments are automatically created. We have already done that. That works surprisingly good, and so the tool can be just applied pretty much anywhere. So this is what we are trying to get done by like a time window of say like 5 months. We actually want it to be done by now actually, but why not? There was some hiccups with the chatbot, and that had a higher priority. So but now we're going back and try to work on that. And the other thing, what I set up a prototype of this a couple of years ago now already, and like we want to revive this project, is basically dataset as code. So what this means is you, for instance, you do have a Freva plugin history, so with an history ID, so that was applied, and you do remember, as I showed you, all the configuration that was stored. So and from this configuration, the system then tries to actually define a recipe of how to create this data set without having to create it. And we also offer another thing like a Jupyter notebook, so the users can chuck in a Jupyter notebook. This thing is then inspecting the Jupyter notebook. You have to give it some tags telling it, okay, here is the output, is the input data. But then we'll be also creating like a dataset entry in the data browser, which will be look like this future kind of thingy. So it indicates that it doesn't exist yet, but once a user actually is searching for this data and then says, hey, just don't give me just the result of this, but executes it. So then the code is executed and the dataset is actually created. And then it's there, it's physically there. And then maybe you can put it in a place where it will be deleted after some time so they can use it. And if it's not existing yet, or it gets deleted, then they can just recreate it, because this recipe of telling the system of how to create the data still exists in the database. And so that's a fairly, I guess, a fairly neat concept that we want to delve more into. And so that would be one of the other things that we want to do in the future. So, and we do have already installed a prototype of this. There's a few things that do not work, is the plugin API, because the plugin API, how the job submission works, it makes an SSH connection, and I did not get this to work with interactive authentication here at Casper. So unfortunately, you have to wait until we have the new API up and running. So that's also for us a good incentive to actually get this going. And the other thing is there on the right-hand side, you can see here, where's my mouse? This little weird username. So these are DKRZ usernames. So because authentication hasn't been set up yet, I just plugged this into our authentication system. But you can log on with, if you want to just give it a try, you can log on with Google, GitHub, LinkedIn. I think that was it. So yeah, it's there. You can search for data. You have we have indexed a bunch of ERA 5 datasets. You can just like give it a play and see. And over the next couple of months, I think you will revive, or not revive, give this some life into this thing. Okay. So, and with this, I'm done actually. I want to thank you for your attention. And I also want to thank all these amazing people that are involved in this thing, because it's not only me alone, it's a fairly big team actually, and there are these people. And thanks to everyone. and I guess I'll take questions then. If there
Right,
are
any questions for Martin? We don't need a mic because we have the ceiling mics.
Do you know what your OpenAI token budget's been lately? Like dollars or euros or close to
How much?
Yeah.
I don't.
Okay.
I don't, because I'm not, like my supervisor's managing that, and I'm not sure. But it happened that we ran out of tokens, and then it was like the big question was, why is this not working anymore? Oh yeah, I need to top up something here. So and then it was okay, but it's not much. But of course, this is just a prototype. We haven't gone like public with this thing. Also, we haven't advertised it. I mean, it is public, but we haven't advertised it. So
Kind of a demonstration.
exactly. So we need to figure out a long-term strategy with this. And the long-term strategy would, like, you run your in-house model.
Yep.
But then it needs to be smart enough to actually not just tell you complete nonsense. And that's the problem.
Okay. Can we use like a different backend if we wanted to? Like we get Gemini here at NCAR and not OpenAI access.
Yes,
We
you
found
could.
that.
You could. You can choose between different some backends. We do have Gemini. We do have DeepSeek. So there's a couple.
Yeah, cool.
So I think it's open source, right? The code for this, is this open source?
Yes, all on GitHub.
And
Or if you go
our-
to that like Freva org, that's our GitHub page, and we'll just redirect you to where that stuff is.
Okay, and then, so we could contribute to like the in-car app and,
Absolutely.
yeah, okay.
Yeah, that would be great.
Please do,
Write
yes.
it down.
Caitlin?
Yeah, I was curious. So, I mean, you showed a bit of the kind of like results display from kind of like the analysis workflow with images and whatnot. But is that, I guess, is that just to like select images, or is that like a full notebook output?
So-
Like, could you display like a whole Jupyter book
So
output and then
yeah,
share
you
it? Or
could.
something?
So this plugin, what I showed, actually I wrote that because the user base for the project that where I started with, they were not really into like programming, and they were not like really the type of like power users. So I wrote this for them, and like I was actually doing this in a Jupyter notebook because it creates a Jupyter notebook, and the idea was then it's like can be also displayed, rendered as HTML, so it can be displayed there, and you can generate a link where you can jump into Jupyter Hub and then just go into that thing, and if you wanted to start playing with this and continue your analysis, because it's just like, load the data, do some plots, but then you want to do maybe something more exciting than that. So yes,
Oh, that's good.
this could be. It's not automatically, it's not an option that is done automatically, you have to define it, but in principle, you can. Also, like data, if this thing only creates data sets, we also have like a little tree that shows you, okay, this is here, this is there, there's the netcd files that were created, and you can see that. And it's not only images.
I understand is this your first time deploying this as a Kubernetes?
Yes, I mean, that's why it took me so long.
Yeah.
And it's like, I mean, we also went to Berlin, this thing comes actually from Berlin, and then we had to completely update it because everything was written in Python 2, and when I started, I mean, I got hired because I needed to rewrite the whole thing in Python 3, and and then actually, like, we went to Berlin to set it up there, and it took me like 6 hours. So it here like nearly 2 weeks. So I was like, but this came from the fact that I've had absolutely no clue about Kubernetes, right? So now I know, and I think now it's awesome. I just gonna come back home and say like, we need that. So because it's really awesome.
So can you talk a little bit about your experience deploying it on Cirrus?
Yeah, sure. I mean, I got a lot of help. Thanks, Kevin. Was really great, and so it's been actually like for me the only thing is I needed to learn like what does that mean in this YAML thingy. That was for me the thing. I got a book, and like I had also ChatGPT, and together we made it somehow. But other than that, it was fairly smooth. So I'm amazed by like how cool that is. But once you know, right? And it's just like with everything. Like once you know, it's easy. So, but it was a steep learning curve, and I'm still like, I feel like scratching the surface there. But it's, yep, with like, it's like support of the right people, and like, it was fairly smooth, although it took quite some time. Because then, of course, like things were not working, and we made like, on the website, we made like within this time here, 4 releases. Because like there was just stuff that we hadn't anticipated. And like also thanks to the people, like, because back home they were also like working on this, to make this happen.
Any other questions? So what type of infrastructure do you typically run through?
So we do have all virtual machines. So we do have a OpenStack, which also supports Kubernetes, but we do not have a license for that. We want to get like now more compute power to set up a Kubernetes cluster, but the head of the systems IT department just said, yeah, we have the budget for that, but we don't have the budget for the OpenStack license. Okay. So we have to see how that goes. But yeah, we just use virtual machines, we all have virtual machines, and there is actually the problem, which I notice now with this Kubernetes. The moment you click and deploy a virtual machine, you're a system admin. I mean, you can log into this thing, and you can do a super user, and like, but you're responsible for that. And if you do something wrong, the cybersecurity guy will come to you and give you a hard time. And this happens a lot.
Right.
So, and with this Kubernetes instance, it's not, because you don't have to worry about it. You don't have to worry about certificates. It was totally mind-blowing to me that this thing is like just generating a certificate. Like, what? I don't have to do that, and I don't have to renew the certificate. And then users come to you, what are you doing? This is like, the website doesn't work anymore because your certs run out. It's like, that's cool. So, and yeah, I mean, it's like, we're not paid for being system admins, right?
Yeah.
We shouldn't be, because like most of them have no clue about that, right? Which is fair enough. So, this is why it's the way to go. This is why I will go back and say, like, we need that.
I got a quick one. When it comes to the steep learning curve, when it comes to adopting things to Kubernetes, what's your main takeaway there? Like, what's important, I guess, to, like, if you were to take it to a colleague and share with them, like, what's your takeaway in terms of what's valuable there?
So my takeaway is everything, like, containerize everything. So that was also, in preparation for this, I had to make sure that all the services are containerized, run containers individual. And this is also why we didn't get the LLM stuff working, because there was things that like work in our infrastructure that didn't containerize it, and like not yet. We are on the way, but like this is my takeaway. It is like if you containerize everything, you can like it's like separate. It's just nice and also reproducible, and you don't have to worry about the architecture or the system that you're running it, because it sits in its own sort of environment.
And then you mentioned the, on-demand ZAR. So is there just a tool basically that converts netcd to some kind of native ZAR store and puts it in cache? Or how does that work?
Exactly. So exactly.
Right.
Exactly.
Yep.
And there are different, like you can do grip. We're also planning on implementing something for our very own tape storage, so that users can access this on tape storage, but that would be, wouldn't be as fast.
Yeah,
because-
no, there'd be a delay.
But still, but yeah, that's the idea behind this.
Okay, cool. I don't think we have anything online, otherwise you would have posted something online, so last call. Otherwise, thanks everybody for coming to today's seminar. Thank you, Martin. Thanks for your